Today we want to take a look at some basics of UIKit, and especially we want to take a look at UIViews and how they work. And the goal for today is to master positioning and sizing of UIViews. So we're going to take a look at that in particular. So first, what is a UIView? So basically UIView is the most fundamental base class in UIKit, and all other UI components inherit from it. And that basically means that everything you see on a screen ultimately is a UI view. So of course there are exceptions to this rule. For example, when you're building a game and you're using SpriteKit, what you see usually won't be UI views, but rather like SpriteKit classes. The same goes for when you need a little bit lower level control about what's happening on the screen, and you need like specific animations, or you have very detailed requirements as to what your user interface should look like. It might be possible or more appropriate to drop down to lower level frameworks like core graphics or core animations. And these are frameworks that ultimately back UIKit. So UIKit basically is a layer on top of these frameworks. So it makes it easier for us to build user interfaces. But in general, most of the UI elements that you're going to see on the screen in regular apps, and certainly in this class, we're only going to work with UIKit and UIViews. So you can safely assume that everything you see on a screen when working in this class is going to be a UIView or a subclass of UIView. So we know that the syntax for subclassing is to use the colon. So class X here stands for basically all the UI classes inside a UIKit, and everything basically is a subclass of UIView. So if we want to take a look at a couple of examples, here we have the UIView class, and one subclass of UIView, for example, is UILabel. So it's gonna have the same characteristics and features as UIView, but on top of that, it also has special features and characteristics that relate to displaying text, right? Because this is what a UILabel does. That's what we're using it for, to display text. Then we also have the UI navigation bar, which is also a subclass of UIView. The navigation bar is the component that you see on top of the screen when you're using a navigation controller that usually displays a title for the current screen. And then we have another subclass that is called UI control. UI control itself is a class that you won't be using, but a couple of subclasses might sound familiar to you. So a subclass of UI control is UI button, UI stepper, or UI switch. And what all of these classes have in common is that they expose certain features that relate to user interaction, right? So UI button, they receive touches. UI switch is the component where you can turn something on or off. So you've got two options what you want to choose when you're using a UI switch. UI stepper is the component that allows you to step up or down an amount that you have inside your app. And if you want to know more about these components, you can go into Xcode in Interface Builder, and on the down right in storyboards, from where you usually drag in the UI components when you're building your UI in storyboards, that's where you find more information about these classes. And note that this diagram is certainly not complete. These are just a couple of examples that I mentioned. And all of these classes have the same characteristics as UIView and certain additional features for their specific purposes. So let's take a look at the anatomy of a UIView. So what's really important to note is a UIView is a rectangle. So it is defined by a frame, and the frame is of type CG-rect, which really is a rectangle. And a rectangle, a CG-rect, has four major components, and that are an X value, a Y value, a width, and a height. So in code, if we wanted to specify a frame for a view, we could just specify the CG-rect with values for these four properties. So for X, Y, width, and height. And this clearly defines a rectangle. A rectangle itself is composed of an origin, which looks like this. If we want to specify the origin, it's of type CG point, and it's only the X and the Y value. And the second part that belongs to a CG-rect is the CG size, which defines the size of the rectangle. So if we want to have a look at what that looks like in code, it's a CG size that we provide with a width and a height, and that way we can clearly define what that rectangle looks like. To go even further down, a CG point consists of an x and a y value, which are both CG floats. In code, this looks like this. And for the size, we have a similar situation where we have a width and a height. Both again are CG floats. And in code, this would look like this.